Hi everyone, we're Anna and Cameron, and today we'll be presenting our work on ReLit. For today's presentation, we'll be explaining our motivation for creating the system's design, final testing, and some discussion. The related work section of a research paper is integral to providing background information on the field and motivation for the project. However, reviewing literature to create this section is time and resource intensive. This is especially so for researchers in the field of deep learning, as there are numerous new studies being produced every month. It may be tempting to use a single prompt to generate this section. However, there's a high risk of hallucinated citations. Further, when asking for edits, entirely new papers can be cited and new content generated. As such, we created ReLit, a multi-agentic tool for deep learning researchers to automate the production of a related works section that accurately summarizes past research and clearly identifies the gap the new research will be filling. This tool will take an abstract as input and output a fully APA-cited related work section that identifies a research gap.
Our system generates a related work section from a single user input abstract. This is done in 3 stages. The first stage is retrieving the papers we'll be citing from the ArXiv API. This starts with a query decomposition agent, which takes in the input abstract and breaks it down to 3 Boolean search queries, which are going to be sent off to the ArXiv API by the retrieval agent. What they get back are papers that we're going to cite, and it parses the PDFs for the text and metadata. Now, not all the papers initially retrieved are going to be relevant to the user's research, so we introduced the filtering agent, which compares each of the candidate papers against the input abstract and discards any irrelevant papers. At this point, we can't simply just pass all the papers into a writing agent because realistically, the input's going to be too long. So we introduced the summarizing and pruning stage to address context window limitation by condensing the information. This starts with hierarchical summarization, where we summarize the documents in 2 passes, first at the chunk level and then at the document level. And at this point, our system generally has a lot of papers. So to cut down on that, we introduced the pruning agent, which takes all the papers in, compares them to each other, and if there's any papers that are redundant or don't present any novel information, then we discard them. Once we have our reduced set of paper summaries, we can move on to writing and evaluation, which starts with the writing agent. The agent takes in the summaries and the user abstract, and it drafts an initial related work section. This gets sent to the evaluator agent, which is going to check the work for citation errors, hallucinations, and fidelity to the original abstract. The feedback gets sent back to the writing agent, and this rewrite loop keeps going until either the evaluator is satisfied with the output or we hit a max retry of 5 times. To summarize, we take a user abstract, we retrieve papers, condense them, and then we write and evaluate the related work section.
So as mentioned, all articles used to generate the related work section are sourced from the ArXiv API. For our full pipeline testing, we created a data set of 10 papers we deemed to be exemplary, and it contains the input abstract, the human written related works, the work cited for that section, and the date published. Several metrics were used to evaluate ReLit's performance. For overall quality, we used 2 evaluators to perform a pairwise comparison, as well as a quality assessment with a rubric. And we also wanted to see if there was an overlap in the papers cited by ReLit and by the human authors, as well as the embedding similarity between the 2 sections. For this presentation, we'll be focusing on the pairwise comparison, the recall, and the embedding similarity results. Based on the embedding similarity results, we can see that there's a moderately strong content overlap between the ReLit and human written related work sections. However, there's a very low citation recall. This is unsurprising though, because ReLit is restricted to only take papers from the ArXiv database. For the pairwise comparison, we asked 2 LLMs, GPT-5 and Claude, to blindly compare the 2 sections against multiple qualitative criterion. As you can see, ReLit wins handily in most sections, save for inaccuracy and factuality, where it only wins 60 to 70% of the time. Based on our visual inspection of the evaluator subsystems flagged issues and the LLM justifications, we can see the major barriers to high accuracy are citation errors and flagged hallucinations. These are often a cause of inconsistent APA styling, overly generalized or highly specific statements made without explicit or implicit citations. Despite this, ReLit's high performance in other categories was repeatedly justified by the LLM evaluator's comments, remarking on its clear progression, professionalism, and explicit gap identification.
The LLM evaluators consistently ranked our related work stronger due to its strong organization, and it always explicitly identifies the gap in the existing research. Our related work sections also generally have high document level alignment with the input abstract, Overall, the generated related works are very coherent, easy to follow, and structured. In terms of limitations, our database is restricted only to arXiv, which can limit the citation coverage. We also only output citations in APA format, whereas a lot of machine learning papers will use styles like IEEE. Our system also lacks a strong ground truth validation signal, meaning stuff like the depth and nuance of the writing or gaps in research doesn't have a reliable benchmark to evaluate against. So we rely heavily on the evaluation of LLMs, which leads to the final limitation, which is that both the writing agent and the evaluator are LLMs, which poses a high risk of model-to-model bias, which could explain our very good pairwise results. Going forward, we'd like to look into few-shot prompting to stabilize each of the agent's outputs. We'd like to explore stronger hallucination checks in the writing, also lighter weight testing strategies, since a lot of our testing relies on external APIs, and finally, to provide access to more databases outside of just arXiv. Thank you.